Now we are going to start gradation. What for? Gradation of aggregate. It's very easy to understand. The gradation of aggregate means sieve analysis. First point, gradation is done by sieve analysis. Now what is sieve analysis? Its answer is aggregates are made to pass through the series of sieves stacked progressively with smaller opening from top to bottom. And this test is performed by Ashto T27 method. In the sieve analysis, when we have the sieve, material is passing, some material may be retained and other material is going down. Just I will give you one example. Suppose I have this sieve, I have another sieve, and I have another sieve. Just for your understanding, over here the material is made to fall. Some of the material is going down. This material which is going down, which I have shown by arrow, you can say that this is known as a P for passing. And some material is going to retain on this one. This is the retained material. Similarly, some material will fall down. After falling down, some material will retain on these sieves. So this is the procedure after the sieve analysis. Passing, retain, passing and retain. So we can say that it is a combination of passing and retain. Progressive opening mean, I will tell you one example. 19 mm sieve is top, 12 mm sieve is bottom, and then 9.5 mm sieve is further bottom. It means the sieve order is being reduced because the opening of there is being reduced. So this example I have shown you over here for your understanding. So this is my sieve. This is my sieve. This is my sieve. Okay. When I am going down, this word I have written. ठीक है? From top to the bottom. Sieve size जो है is being reduced when we are going from top to the bottom. So over here, let me tell you now why this gradation is important. Why it is very important factor. Gradation, very important factor. As I have already explained to you, you have the gradation with you. When aggregates are combined with each other, you have to select such gradation where you have the provision of volume of voids. When I use this word provision for the volume of the voids, air voids, means when these aggregates are going to mix with binder, proper film or proper coating to be done. If there is no any air void, proper coating will not be done. First point. And second point, when these aggregate, when mixed with the binder, it is hot mixed spot. We have to lay down it. It has to serve as a road. When it is being serving as a road, it is clearly mentioned in all the books, in all the specifications, that some pocket of air should be over there. Why? To provide some space, to provide some tiny space that whenever the aggregate and this binder content are going to show the thermal expansion behavior, there should be some provision. So that's why next we can write on also provision for expansion. Of binder or more compaction during service. Life. That is why this we need to be select gradation very carefully. Now, next I will tell you this mathematical procedure that when you are going to work either in the laboratory or when you have to develop the report for this gradation, how this gradation will be tabulated. So you can say that sieve size, after that retention weight, next is the retention percentage, and last one is the passing percentage. It is very easy to understand. Even you are either as a field engineer or you are the student, whenever you have to do with the work with the asphalt, this gradation is very preliminary part. So we are developing the Superpave for the asphalt wearing course. The first sieve over here, 19, 12.5, 9.5, 4.75, 2.36, 1.18, 0.6, 0.3, 0.15, 0.075, and next one is a pan. Why pan? Because when some material will pass through the sieve, it will be retained on the pan. And at the end we are going to get total. Okay, how much of the material? For example, I will not make the calculation, just I will tell you. Okay, over this, how much is the retention weight? I say weight is 0, it means all material has been passed. Over this sieve, how much weight is retained? Because I have taken the material being retained on this sieve, let us suppose it is 30 gram. Just I am giving you one example. How much material is retained over here? I say that it is 85 gram. How much material is retained over here? 210 gram. How much material retained over here? You can say that 130. How much material retained over here? 75, 65, 50, 20, 10. How much is in the pen? 5. All this would be made your sum over here. Let us suppose that this sum is represented by capital T. We have to find out the retention percentage. So this retention percentage can be find out. This retention weight divided by this T total into 100. We will go on applying this formula and we will find out the value for this retention. Over here retention is 0. It means 100% material has passed. We will go on subtracting this value and we will go on adding. So in this way we are going to get our percentage of the material passing through the each sieve. So it was the just brief introduction. I have not filled all this column. Next please all, you should have to practice it. You should have to make this calculation. You make this total by this formula. Try to find out this retention percentage. Here I have shown you this minus this. Like for example 100 minus 7, it will be 93. Suppose here come again 8, 93 minus 8, it would be equal to 85. Like this way. In this way you will have to fill this column. Okay, this minus this, this minus this, this minus this. Like this is the procedure, zigzag procedure. So thank you very much for seeing this one. If you have any doubt, I am ready to clarify it. Thank you for seeing this.